So in this video, we'll be trying to draw the project network diagrams. So we'll be using whatever data table that I gave here to see if we can actually sketch this whole thing. So I'll use let me just use this format throughout. It's going to be like this. I don't like that. And then here we're going to be really start the activity. Let me call it A. Early finish. Late start. CP duration. Let me call it D. Late finish. So this is going to be our standard format of thinking about this. So I think I've mentioned every parameter it is there. So yeah. So we'll keep on. So let's start just now. Okay. So we're going to have A. This guy is connected to nothing, and we are going to have B and C, both of them connected to A. So I'm just going to paste them here. What are they? It's going to be B, and I'm going to paste another one, and C, both of them are connected to A. So I'm just following exactly that. And then D is connected to B. Just paste. And then what is it? Here now is connected to D. D is connected to B, like that. And E is connected to C. This is our E. And F is connected to both D and E. And that's our F, right? So bottom, I'm going to have durations throughout. A will have a duration of 4. Oh, sorry, I don't know why I said 4. A will have a duration of 5 because I'm copying just here. B will have a duration of 4. C will have a duration of 5. D will have a duration of 6. E will have a duration of 3. F will have a duration of 4. Alright, remember activity, duration, early start, early finish, late start, late finish. So we're doing that now. Okay, let's zoom in. Early start here, 0. If we add duration, we're going to have 5. And then we take the 5 here. This is going to, both are going to start at 5. Now this one will add and that will get a 9. This one will add and then we get a 10. And then this 9 is going to start here, and then add a 6, we get a 15. Come here below, we're starting with a 10, adding a 3, we're getting a 13. Alright, and then here this node connects to two different times. So we're going to pick the max between this and this, because remember, for this activity to happen, we need both of them to be done or successful. So for both of them to be successful, the longer one will have to be successful first. So we'll have 15 here. 15 plus 4, 19. Alright, and then we're going to count back, obviously. Okay, so we're going to end at 19. Okay, let me use a different color. So now we're starting at 19, minusing 4, ending at 15. So you can just put 15 both sides. And then minus a 3, I'll end up having a 12. And then minus a 6 here, and then end up having a 9. And then a 9 jumps here, 12 jumps here. Minus a 5, get a 7, minus a 9. Remember, at the time I was going forward, I was adding, now I'm going backward. So you're expecting that I'm actually subtracting. you'll see the inverse around all these things. And then if I subtract a 4 from the 9, I'll get a 5. Then here, remember when we are trying to jump into a node that is supplied by 2 path, we're actually choosing the max. Now if we're going the other way, we'll have to choose the what. This was the max. Now we'll have to choose the what, the mean. So the mean between we are on below path between 5 and 4, we'll have to pick 5, then minus 5 0. And if you ever happen to land on 0 here, because time starts at 0, that means you did everything correct. So if you understand this part of the video, congratulations, you understand at least one most fundamental part. So the next part of the video will be you trying to find float or slack. So think here is float or slack. Float is how much days an activity can be delayed such that you don't change this final time or finish time, right? So you can find that by subtracting a lower finish minus earlier finish, or other way around of lower start minus late late finish. So either way, any of them you subtract, you're going to land on something we call float. So let's come here. So if you subtract here, this one is going to be our TF total float is going to be 0. Here if I subtract here, it's going to be 0. If I subtract here, it's become 2. If I subtract here, become 2. If I subtract here, it becomes 0. If I subtract here, it becomes 0. So yeah. So then from then we'll define something we call a critical path. So critical path will be a path where all the slacks or float are 0, meaning you can't really you can't do anything wrong with those activities. This will be on time. I don't know, use the wrong word that's actually thought about, but technically I would say you can't fuck around these times. You have to be on accurate time and due date. So this is 0, this is 0, this, and then they call this path critical path. So if you think about it, if you delay an activity, maybe this activity specifically, you already have a float of 2. That means you have a cushion. You can be late or early or whatever way, but you have a cushion of playing around with that activity and this activity. So activity C and E, you have some cushions to play around, right? But when it comes to, if you delay anything on A, B, D, F, you actually getting it wrong now there, because any delay you make will actually end up making the final time being delayed by whatever activity, the amount of time it delayed in that activity, if that makes sense. So that was the second part of the video, and this part marks the end of the video. So second part of the video, it will be me having data and trying to do this thing on Excel. Hopefully it will work fine. So please check out the next video, of which will be me doing this thing on Excel, of which is more, I don't know, the way that you're most likely going to use it in application, not in paper, because you want to, if you change maybe some parameter here, everything just changes the end time so easily without you having actually to recalculate as much as I'm doing. So the path that all the floaters like 0, we call that critical path, because you can't actually play around it. You have to be on time at all times. Thank you for watching.